my background.
Tell me about your background, Bart. Why do we have you on the air today? Tell us about Bart.
Good. Hey, good question, Al. Which sincerely is a good question, because anybody out there watching right now may be asking, why is Al talking to this guy about the digital craftsmanship in the CAD/CAM landscape? So a little bit about my background. I've been in this a very, very long time. I've been in the CAD/CAM world since I'm 18, actually, which you may have noticed is a long time ago based on the color of my beard. That was a very, very long time ago.
Right.
But I started right out of high school. I was actually in the second class of the first and only of its kind at the time accredited CAD/CAM technologies degree program in the country, in the U.S. So that set me right out. It was a very hands-on curriculum, and at 18, I started working with CAD/CAM. After I got my degree and graduated, I started. I was a user and a system administrator at a few different companies. Some very small. Like my first job was in Portland, Maine, just down the road from this lighthouse. My job was literally just a couple miles from this lighthouse, and I lived near it. So whenever I see it, it brings me back to my first job. But I also moved around, and not only was that was a very small 10-person company. It was great. It gave me a lot of exposure from not only designing a part in a CAD system if I designed a part, literally the next day I'd be out at the 5-axis machine running it and cutting the part. But I was also in large companies like Xerox. That was my user side of it. But about 30 years ago, I moved to the solution side and started offering CAD/CAM solutions to customers. I was an integrator for a system, and eventually became an applications engineer and a regional manager for GibbsCAM. Then about 7 years ago, I decided to come back out and be a reseller, which I really, really enjoy, because you're working with the customers and working with providing them solutions and helping them make sure that they're successful with their CAD/CAM and with machining their parts. So really, in my nearly unbelievably 40 years in the CAD/CAM industry, I've been in a lot of different positions, which, kind of gives me a unique perspective on the CAD/CAM industry. I've seen it from many different sides. So that's why I'm here. Oh, I can't hear you, Al.
You're well versed in the industry, that's for sure. It's incredible, really, to have known you that many years and not know that you started at a college degree about CAD/CAM. I had no idea.
Mm-hmm. Yeah. And really, the second class of the first and only one was a little rural college in upstate New York that had the first accredited program, which was really just incredible if you think about it. It wasn't some big university that had the first program. Was some little tiny ag tech school.
Crazy.
Yeah, really is.
So, Bart, you're younger than I am by enough that in the days of computers, it makes a big difference just a few years. And certainly in my days, we're still using punch cards and compact 2 and F. So yeah, you started just a little bit further ahead, probably on an 86 chip computer back then. I'm going to guess.
So, I did jump into the curve of CAD/CAM a little bit further ahead than you, because I never really did do the punch card or the manual programming or anything like that. I've been strictly CAD/CAM my whole life.
Wow.
Yeah.
So in my world, of course, all we did was manual programming, but things changed.
Which is a strength, right? It's very much a strength. And I would encourage anybody to start learning manual programming if they're going to get into CAD/CAM, if they're going to be a machinist. Even though you got the tools and the technology, it does not hurt to learn how to manually program first. It really doesn't.
It sure is at least nice to know that you can turn coolant on and off, and potentially some other things that may change a tool or change an offset. Those are always handy to know manually. But we can go down that hole for a while. Yeah. So, Bart, let's start with our first question. We traditionally start with 10 questions. I don't know that we'll get them through all of them in an hour, but it is,
Okay.
important. And since you went to college and everything, maybe you can introduce to us what CAD/CAM stands for, if you would be so kind.
Sure. So CAD/CAM, right? CAD, computer-aided design, it's for the designers, and then CAM, the computer-aided manufacturing. But if we go all the way back to the origin, the beginning of this stuff, which I really say, even though this technology evolved in the 70s, it really took off in the 80s. And one of the things I find interesting is today CAD is just CAD, computer design, but actually initially it was CADD, computer design and drafting.
Yeah.
Which was what was originally used for the CAD system, or the CAM system was largely used as an electronic drafting system. So CAD was computer design, but CAM obviously is computer aided manufacturing. But that's a very large topic. There's a lot of debate out there as to what is CAM. In the early years, it covered a very, very wide breadth of solutions for manufacturing, but in the last 25, 30 years, it's really become synonymous with CAM software, or software for creating toolpath and G-code programs. And like I said, the CAD/CAM technology had been around since the 70s, but they really became viable in the 80s. In my opinion, Computer Vision, the company based out of the Boston area, is really the grandfather of CAD/CAM. They're the ones that really got it out there and made it a viable solution, and which was adopted by really the large DoD, the government, the large corporations at first, which is understandable because a single CAD/CAM station was $250,000 at the time.
Yeah.
But those were Unix-based systems, and eventually they gave way to the PC-based systems that really took off in the late 80s and into the 90s, and that's when 3D modeling really took off, was with the introduction of the PC-based system. So yeah, CAD/CAM, computer-aided design and computer-aided manufacturing, just the technology that's started in the 70s, took off in the 80s, and then really has just been on jet fuel for the last 25 years with all the innovations in technology. I look back at what I first started with. Quick story. One of my first jobs, we had the first version of an IBM XT. It was dual floppies. We got Personal Designer, which was one of the first PC-based CAD/CAM systems. And the owner of the company was looking for investors. He said, hey, next day there's going to be some investors coming through, and his sum total instructions were put something cool on the screen. So we took one ruled surface, we rendered it overnight. It took all night for one ruled surface, and the next morning we had a single ruled surface, and everybody was excited. So now compare that to today, where you have instantaneous rendering of complete machine tools and parts and assemblies working in unison instantaneously.
That is pretty phenomenal, really, when you think about it. When you look at the history where we are today, it really is pretty incredible.
I've often said I wish I still had that IBM XT with the dual floppies in that software, just to show people where it really came from. And you often ask, how did it survive? Because that was almost virtually useless in the beginning.
It took forever to see a line draw across the screen. You think, well, I could have written the code by then.
Yeah. Exactly.
No, it really is an interesting legacy there. And, CAD and CAM, you're right. When you think about it, Bart, certainly Mastercam has been around for a long time.
Mm-hmm.
And I bring that up just because they really started in the offices of CAD Key.
Yep.
And they really started as a CAD system that, started with that legacy, right?
Yeah, a lot of the CAM systems started as a derivative of a CAD system, which in some ways helped, in some ways hindered them, because as we know, CAD systems think like design engineers, and CAM software thinks like programmers and machinists, and that's completely two different schools of thought. And so if it was a CAM system based originally on a CAD system, it didn't really optimally lend itself to a CAM programmer and machinist.
Yeah, exactly. You could see the heritage of certain systems based on where they're initially started. So, back from that moment for them, their legacy still kind of shows the old CAD style interface as opposed to the, we'll say,
Yep.
pure CAM style focus.
Right. A software that thinks and acts like a programmer and a machinist.
You got it. So, all right. Question 2. Importance of CAD/CAM. Why is CAD/CAM technology critical in modern manufacturing and design process? Why does it need to be here?
Well, primarily because there's no more drafting boards left. Nobody has a drafting board anymore, so we can't find them and nobody can use them. No, just joking. But it's because the CAD model drives all downstream functions and things. So it drives everything from the design of the part to the manufacturing of the part to analysis of the part, like wind analysis, stress analysis, stuff like that, all the way down to even documentation, product documentation. They use the CAD model to do all of this. So the CAD model becomes very, very critical in the whole thing. That's where it all starts, and it drives everything downstream, the CAM software being one of those downstream functionalities. And specifically to the CAM world, it's the model that we use, the CAD data, because we don't want people redrawing it, right? Is the CAD data is what drives the CAM software to create the really accurate and efficient tool path. Without a good model, we don't end up with a good part that comes off the machine. Another thing that's just very, very critical, why CAD/CAM is so critical today, is interoperability. In the early days of CAD/CAM, getting your CAD model, your data over to the CAM software or anywhere downstream from design was a challenge. It wasn't a given. But today, it's a given that you can read just about any CAD data from anywhere. It should be as ambiguous as turning on the lights, right? It's no longer a differentiator. The other thing that CAD/CAM and especially CAM allows us to do is take advantage of all the capabilities of these machine tools today. The machine tools today are not your grandfather's machine tools. They can do so much more. But it's like a relationship where we kind of leapfrog each other because of the CAD/CAM technology. Machine tool can do more, and as machine tool do more, CAD starts doing more. So CAD/CAM allows us to take full advantage of the machine technology. As an example, right? Swiss or MTM technologies with B-axis milling spindles, things like that. Another great example is volume mill, right?
Sure.
Because of volume mill, a technology that was born in the CAD/CAM world, we can drive old machines to perform better than, quite honestly, they were ever designed to, because we use CAD/CAM technologies to do it. And we can make old machines feel like puppies again.
We can make machines that aren't that great look good.
Absolutely.
I remember doing a test with a machine manufacturer I won't mention, but on a C-axis lathe, if you were trying to cut a flat while you're rotating the C-axis and moving your X-axis along, you're basically, moving up and down on the part. And some of those lower cost machines, in fact, you couldn't cut a flat that way.
Right.
But you could design the failure in the CAM system to compensate for it. So you could put in the rise or you could put in the fall where the machine wouldn't allow for that flat to be made. You could now generate a real flat based on the CAM system fixing the failure or the backlash or whatever you may want to call. Yeah. Right. Good point.
Well, that's a great example of saying how machine tooling in CAD/CAM all have a symbiotic relationship. And a lot of times one drives the other. So in the case you just illustrated, the software was driving what the machine could do. Volume mill was driving what machines could do. Tooling, on the other hand, now that we have like barrel cutters and these high-speed roughing end mills and everything else, is driving what machines and what CAM software can do. So it's a very symbiotic relationship between machine tooling and CAD CAM software. And as one advances, the others catch up, and we just keep leapfrogging each other.
Yeah, no, absolutely.
It's a great thing, because you don't have to rely upon one product continually driving technology. They each keep driving each other.
Yeah, absolutely. So, all right, well, let's go to question number 3. I think we're doing great here. So, industries and applications. In the end, which industries do you think have been most significantly transformed with CAD/CAM? And I can think of several examples, and probably you can too. But fire away.
And the interesting thing, Alice, we'll probably have, this has never happened before, but me and you have different opinions. I'm sure that's never happened before, that you and I have different opinions. No. But so if you ask 5 different people, they'll probably give you 5 different answers. And for me, I really say all industries, from small general machine shops to large tier 1 providers to large DoD and aerospace companies and more, have all benefited from the CAD CAM technology, all of them. But if I were to pick one, believe it or not, I'd go with the general machine shop. And the reason I go with the general machine shop is because of CAD CAM technology. They can now provide machining services that they otherwise it used to be only large companies could do. As an example, take MTM. Because we now have multitask machining software capabilities, in other words, the ability to drive rather complex machines like multi-turret, multi-spindle machines, all right? General machine shops can go out and buy the MTM machines that really were the hindrance to them getting it was programming those machines, right? Now they can go out and buy a nice Haas DS30Y, whatever, and now, a fairly complex machine that they can now program because they have this CAD CAM technology. So if you keep following this stream of thought, now that general machine shops can do it, producers or manufacturers can get their parts sooner, they can get them cheaper, they can get them faster, they can get them more well made. So because of CAD CAM technology allows these general machine shops to program these otherwise complex machines, it really just feeds the whole manufacturing cycle.
That's an interesting perspective, because we were talking about how things started in the 70s, and reality is, yes, even in the late, you know what the first CNC machine was, don't you? Let me rephrase. You know what the first NC machine was, don't you?
I do not.
The player piano.
I'm not as old as you, Al. I'm not as old as you. Remember, Al?
Even
although I look it.
I'm not that old, but the player piano was the first. The player piano and the rug making world, tapestry making world were the first industries to get into that, where the cards would come through, and obviously the piano would play, and the tapestries would run through, so you'd get the same look. But when we started with the Moog and we started with those early machines, they were really designed to handle complex profiles of helicopter blades.
Yeah,
and that's where that industry started taking off.
I'm not often caught off guard. I'm not often surprised, but you did just surprise me that I didn't know that the player piano and the looms, the program looms, were the first application of CNC. Interestingly, you mentioned Moog. Moog was right up the road from my college, and I had about 4 classmates that went to work for Moog out of my CAD CAM technology. So, and in fact, I think 2 of them are still there, to be honest. So,
you remember those big dials on the Moog? Mm-hmm. Oh my goodness, they have fixed offset locations on the table.
Oh, yeah. Well, I mean, look, we talk about CAD CAM and computers today. Look, we went from a dual floppy drive IBM XT to the crazy computers we have today. But same thing with machine tools, right? If somebody today that just came into the machining world were to look at an old Moog, they'd probably go, "What the hell is this thing?"
Yeah. Yeah.
Incredible changes in really a short amount of time, 30 years. Incredible changes.
Yeah. I'm going to agree with your comment about general machine shops, but certainly, as with most things, certain industries push the landscape further, whether that's aerospace, certainly, in the military stuff. I mean, obviously, we're trying to get things done better, faster, and smarter, and being able to leverage your design digitally has made a big difference in that industry. But, even just simple things, as you were saying before, the manual guy on the manual lathe or the mill would create some toolpath that was efficient, but they would use files and they would use other things to deburr the part. But when we got into the world of NC and CNC, we could start doing things where you could create a chamfer and a radius on those chamfers and do some things that were making that part so much nicer to hold and work with.
Well, and just take it off the machine and you're done. But the chamfering or the deburring, is a great example of machining drove software. Meaning the machinist went, yeah, this is great. I can make my entire part, but when I take it off, I got to deburr it. And we're going back 20 plus years, right? Mm-hmm. But then the CAM software went, well, hold on. We can do deburring. We'll make it so that you don't have to do that. And again, this just goes back to my principle, which is one just keeps feeding the other, driving the other.
Yeah, absolutely. All right, so let's get to question number 4, skills and training. What skills and training are essential for professionals working with CAD/CAM systems?
Well, I'm going to say something that sounds absurdly obvious, but I'm still going to say it anyways, and that is, to be successful, you have to have the ability to navigate around a PC and, more importantly, the operating system. So that's a must. We worked with, in the very early days, we spent as much time teaching people how to operate a computer and how to operate a operating system. And believe it or not, I remember a class where I was teaching somebody how to use a mouse. In today's world, that seems absurd, but in the world of 1993, that isn't so absurd, right? So navigating around, because software now is prolific when you install it, it becomes very prolific throughout your operating system, and you have to know where files are stored and how to get to them and how to save them and so on and so forth. So the ability to easily navigate around your PC and operating systems is absolutely crucial. But in regards to CAM software specifically, the things that will make you successful, that when we're training people, the people that know G-code, they can read a G-code program. Okay, they don't have to be a machinist or a programmer, but they can read a G-code and they understand what M08 is. That is very, very helpful. As is, again, sticking on the CAM software side of it, is having an understanding of machining, tooling, fixturing, that type of stuff. This becomes very important. In fact, I've often said to people, I said, if I owned a machine shop or if I owned a company that we did machining, I would make whoever became my programmer or even my designer, quite honestly, go out to the shop floor for the 6 months and get an understanding of tooling, toolpath, fixturing. Because when you do that and then you put them in the CAD/CAM room, makes them far more successful. Can't tell you the number of things that end up coming down to the shop floor, and the machinist has to go back to the designer and explain to them why they can't machine it that way, or they can't make this part. So these are the things that I think are very, very crucial for the professionals to really be successful. Understand the technology, but I guess the way to say it is understand the technology, but understand the underlying application. Know what you're using CAD/CAM for, to program a machine, to make toolpath, to make a part. Understand how that all works. Then you can really apply the technology much better.
You know what some insurance companies are saying is the best deterrent system to stealing somebody's car?
A manual transmission.
A manual transmission.
I have one.
Exactly.
Mm-hmm. Yeah.
Now, I have a manual too. I didn't buy it for that reason. I bought it because it was a lot of fun.
Yeah.
I like, driving a manual because you have full control. So having an automatic, which is probably the most complex they say it's one of the most complex engineering systems created, really, that allows somebody to put something in drive, and now you have 6, 8, 10 gears in your transmission that allows you to get there. And what do you have to learn? You have to learn how to move that thing to the D, and then you can drive.
Yeah.
When it comes to CAD CAM, it's interesting, but there's a lot of CAD CAM systems which are really, really good, but some of them are really, 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 really hard to learn.
Yeah.
And I think of one, and I'll say the name, I'm not embarrassed. It's TBIS. TBIS is a great CAM system. It makes incredible toolpath, but I think, even a rocket scientist would have a hard time trying to figure out how to use that thing. It's just brutal.
And I'm sorry to cut you off,
Yeah,
but,
no,
but
that's okay.
the same for integrated systems, right? So in the CAD CAM world, you have the integrated system, which does A to Z. You have the embedded system, it's the CAD system that embeds a CAM system inside of it. And then you have the standalone. And generally speaking, it's the integrated and the embedded systems that become more challenging to learn. Everybody says easy to use. Well, everything is easy to use once you learn how to use it.
Yeah, exactly.
It's a matter of how long does it take you to get to the point where you say, this is easy to use. So that's the learning curve, right? So I believe in the CAD CAM world, the standalones are the easiest to learn because there's fewer buttons, less overhead. You don't have a lot of menu selections there to have absolutely nothing to do with the job you're trying to do, such as create a toolpath.
Yeah, and it's nice to have a piece of software that, whether you're in, lathe or mill turn, the interface stays the same. So you're not having to kind of relearn a different solution for each module type.
Absolutely. So you got to figure out what type of system you're using, and then based on the type of system that you're going to use, that will determine how easy to learn, how easy to use is it, how functional is it for your part of the job. Again, an integrated system goes from A to Z, but any one person is only doing one part of that entire job scope. So they only use one part of that software. Therefore, is that part of, does it do the job I want it to do?
Right. Well, beautiful. Okay. Well, let's get on to the software and tools. Question number 5 there, Bart. What are some of the most widely used CAD CAM software tools, and what sets them apart from each other?
Well, we're actually touching upon what we were just talking about. So to me, what sets them apart is are we talking about an integrated solution? Are we talking about an embedded solution? Are we talking about a standalone solution? So for this conversation, because this is the world that you and I live in, which is the standalone world, we don't really work in the integrated world. We don't work in the embedded world, the standalone solution. So in the standalone world, on the CAD side, obviously, and you probably know more about the CAD solutions than I do at this particular point in my career. But, I see on the CAD side, the standalone world, the big ones are the SolidWorks, Inventor, and SpaceClaim to me. I know there's NX and I know there's other ones, but those are more the integrated solutions. So I didn't include those. But, so you got those 3 on that side. And what differentiates those 3? Again, from my perspective, what differentiates the standalone in the CAD space is the modeling. So for example, is it a history-based modeling system like SolidWorks? Or is it a freeform modeling system like SpaceClaim where you're uninhibited by the history? So I really think it's the type of modeling that differentiates the CAD systems. Now in the CAM system, more specific to what you and I do, Al, I believe that the big 3 are Mastercam, GibbsCam, and Esprit in the standalone space. I don't think there's much argument there. Other CAM systems may say they are, but I would respectfully disagree with them. And what sets them apart, usually, quite honestly, is the type of machines that they support. As an example, for example, I know GibbsCam. So on the GibbsCam side, one of the things that separates us from other CAM software solutions is our ability to support the more complex machines, such as computer, such as multitask machines, where you have more than one turret, more than one spindle. And some of these machines start getting crazy. I mean, you and I were just talking about a machine where it has one turret, tool sticking out both sides. The main spindle stays stationary. The tool moves over the part, but then the sub spindle chases the tools on the back side of the turret, and does all the machining on the sub spindle. You throw a lower turret into that scenario, you're getting into some very complex machines, which quite honestly, nobody's going to program manually. They're just not going to do it. So in the CAM space, it's the type of machines that can support. And I wouldn't badmouth them, but I mean, Mastercam has their strengths. There is no doubt. There's a market segment that they focus on, and they do very good. Same with Esprit. But I think in the CAM world, what separates the CAM systems, you can get into the untangibles like easy to use, easy to learn, clean interface, yada, 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 which are all true. But I think what it really boils down to, it used to be, interoperability. What CAD files can you read? That's not a differentiator anymore. The interface is still a differentiator, but not as much as it used to be. I think the main differentiator today is what are the type of machines that you can support?
Well, I think you're right. I mean, that is certainly a piece of it. What machines can you support? But I also think the ecosystem is important in the sense that can you manage, probing, for instance? What external systems can you incorporate? What automations are able to work inside of a CAM system? I think by now, most people, whether it's the free stuff they can get on the web or almost free stuff, they have some type of solution so that they don't have to write code by hand. I would say there are very few people who are still learning to write code by hand. So that we'll say that those days are gone. Right. But now I think it's becoming more about automation. How can you interface things? How can you bring things in? And if your CAM system is open enough, it's going to allow you a greater depth of growth as a company, right? So beyond the things you just mentioned, having that ability to manage external systems, I think, is important too.
Yeah, I would agree. Automation becomes very important. Not only what automations does your CAD CAM system allow, but what levels, and you and I have talked about, and we'll probably get into this later, but, what different levels of automation are available to you. But yes, being able to automate is definitely a differentiator.
Beautiful. Which exactly leads us into question number 6. So that's awesome. So advancements in trends.
Yes.
How have recent advancements in technology such as AI and machine learning impacted the CAD CAM landscape?
Okay. Again, you and I may have slightly different opinions about this, but I would say this. It hasn't yet. It hasn't yet, but believe me, it's coming. So AI is in its infancy in all different sectors, all different applications, not just manufacturing, right? But at the moment, I don't think it's greatly impacted CAD CAM yet. And I say that with capital letters because it is coming. As proof positive to that, I was just attended the Gibbs CAM Global Reseller Conference, and it was a 3.5-day event. And in those 3.5 days, I can't tell you how much was discussed about AI and how it's going to impact the CAD CAM world, how it's going to be incorporated into Gibbs CAM. And I'm sure every other CAM system out there is doing the same thing. We're not the only ones, but it's coming. And soon it'll be used in many different ways in the CAD CAM world. As an example, it'll impact how we train the software. It will impact how the toolpath is generated. Heck, there will be even technology that will take existing toolpath and rewrite it to optimize it. So, AI combined with cloud space type of applications, you're going to see a very, very big AI footprint in the CAD CAM world. It isn't here yet. It's very much in its infancy. But in today's world also, we all know that technology is becoming quicker, 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 and quicker. So even though AI is in its infancy today, 4 and 5 years from now, it'll be very mainstream. And each CAD CAM software will determine how they use it within their application. But it's there, it's coming, and it's very exciting. I really believe because of AI, we're on the brink of the next generation of CAD CAM technologies. As with many sectors are going to be impacted by AI, but in the manufacturing world, we're on the precipice of the next generation of CAD CAM technologies.
Well, well said, Bart. I mean, I agree with you. We're seeing all the changes happening already. We're already ChatGPT 5.0 is being discussed. We have ChatGPT 4 Omni. We have Sky. We have all kinds of things that are happening in all types of industries. And part of this growth, you want to say it's necessary, but this whole thing of robotics and AI have become more pushed in the last few years just because there is such a hard time finding skilled labor.
Yeah, exactly.
So we're trying to find solutions to this, to maybe humanity's detriment. I don't know how chaotic this is going to be, but the reality is, we're always leaning to technology to help things move along.
Right. And like I say, everybody, to me, I just tell people it's coming, embrace it, know that it's going to be here. Know that in the beginning, it's going to be a little cumbersome. It may not work exactly right, as with every technology, starting with the fire and the wheel. The launch doesn't go smoothly. But eventually it will be very ambiguous in the CAD CAM world. And we'll say this: how did we use CAD CAM before AI? We really will. I mean, just like we say, we program some parts, very complex parts on very complex machines, and go, how did we used to do that before CAD CAM? And the answer is we didn't. So we have to embrace technology.
We do. Yeah. And I guess with years, we start to see the changes, but it just seems like, it's several months now. It's not years, it's months on. Yes. It seems to be compounded. Like you can't manage to keep up.
No. It's what's that? It's not Murphy's Law. What's the law that says that technology keeps doubling on itself? And again, even go back to 20 years ago, the technology was taking years and years and years to get incorporated, to get adopted. And like you just said, now it's months and a year. That's why I say AI largely isn't impacting CAD CAM now, but in 4 years, it'll be very widely used in CAD CAM, and starting in 2 years or less.
And we're using it not only to, for instance, in Tool Manager IQ, we have it embedded to help users, but we're now using AI to help us develop the software.
Yep. I mean, I saw one technology that allowed you to program a part. You send the part program, the actual CAM program, the file up to the cloud. AI looks at it, re-engineers the toolpath to optimize it, sends it back down to you. So now you have an optimized program because of AI. And this is all coming at us, and it's coming fast, really fast.
Yeah, absolutely. All right. Well, let's move on then to question number 7, challenges and solutions. What are some common challenges faced by the professionals using CAD CAM, and how can they overcome these challenges?
Well, you just touched on it a minute ago, honestly, and that is the biggest challenge facing the manufacturing world, the CAD CAM world, is the lack of skilled labor. The ability to go out and find a qualified person, finding them, hiring them, successfully onboarding designers, programmers, and especially machinists is the biggest challenge. It truly is. So we've got to overcome that challenge. So really, in my opinion, it really boils down to training. The more people that we can get the skills that they need to be a successful CAD CAM or a CAD designer or a CAM programmer, machinist, the better off we are. Now, I think the good news is this. We just talked about AI. AI is going to bring even more training options available. But right now, in today's world, there's an incredible amount of training resources out there for CAD CAM. I mean, just an incredible number that range from, self-paced online training to virtual classroom instructor-led training to in-person, but even just online. So and there's a ton of free training opportunity or resources out there that users could go look for virtually any CAD CAM system. The amount of information out there to train yourself is incredible. And like I said, with AI coming, I think one of the biggest first impacts of AI on CAD CAM will be in the training space, the ability to do it. So I think getting the skilled resources is really the biggest challenge that we face. Everywhere I go, especially machinists or such skilled people, they're saying we can't find machinists, we can't find programmers. So they're making up for that through what? Automation, like you talked about, through robotics, through other things, unmanned, lights out machining. They're starting to use automation becomes far more important. But some people have to know how to implement and use the automation.
That's yes, well said, Bart. I mean, obviously, again, this is one of those topics that we could go in a few different tangents.
Yeah.
The technology is coming to a point, even in the world of 3D printers and 3D manufacturing, which also touches, of course, in our world of CAD CAM, as things are getting directly from CAD to manufacturing. They basically go to a printer, and it effectively creates a part that can potentially be used immediately into a manufacturing process or can be secondary to some machining.
Right.
But ultimately, getting people to embrace the technology. So I think maybe on this point, as I do generally during the show, is get young people who have tuned into this to embrace it. Don't feel defeated that AI is going to take us all over.
No.
AI still needs to be driven by humans. And there's an opportunity here where that can happen.
How to meet driven. Yeah. I would agree with you. People used to there used to be street lamp lighters, right? The guy would walk around and light all the street lamps. And then they said, well, technology came along in the light bulb, and they said, well, you're going to take all the jobs away. Well, no, now you need the jobs of the people that install, set up, maintain the street lights, that develop new technology and everything else. It doesn't take jobs away. It just shifts the jobs is what technology does. So, yeah, Al, real quick tangent.
Yeah.
We do have a skills gap in the world, but especially here in the US. We pushed kids away from trades for so long, but I'm seeing it's starting to come back, and people, high school counselors and everybody else is starting to guide them back to, hey, not everybody needs to go to university. We need the skilled people. And now I go to trade shows, and what I'm really encouraged by is, like, a lot of these trade shows will set up one special day just for students, and you talk to them and say, you're on the right path. This is exciting technology. You're going to be using AI. Today's manufacturing is not your grandfather's manufacturing. It's a high technology field. So I'm encouraged by what I'm seeing with the trend in younger kids going, wait a minute, manufacturing is a really cool opportunity for my career.
Absolutely.
Exciting.
And that's where I think parents and educators who really care about their kids can help push their children in a direction that will allow them to be useful, not only for themselves and their families, but for the countries they live and work in.
Yeah. And again, the other nice thing is, for the young kids that say, I'm going to go down the manufacturing road, there's jobs aplenty. There's opportunity waiting for them. And they're going to have a very good career, and there's a lot of growth opportunity in those careers for them.
Absolutely. Mm-hmm. All right. So question number 9, future of CAD CAM. What does the future hold for CAD CAM technology? And what emerging trends should we watch for?
Well, you and I talked earlier about what drives CAD CAM, machine technology, tooling technology.
Yeah.
As those things become more advanced, more complex, more capable, the CAD CAM software has to. And sometimes the CAD CAM software becomes more capable, which drives machine technology. For me, I see a lot of exciting trends. AI, as we've already discussed, we won't go down that road anymore. But here's another one. I mean, the multitask machines really took the world by storm in the early 2000s. All of a sudden, these became all of a sudden they started popping up in general machine shops. And once you see machines popping up in general machine shops, you know it's that technology has been truly adopted. Well, I think the one that we're on the cusp of right now, and you already mentioned 3D printing, is hybrid. Hybrid machining is coming. And the application of hybrid machining, for if there's anybody out there who doesn't know what we mean by hybrid, and that is one machine that can both do subtractive and additive. Additive being printed, hey, lay down some material, print some material. Subtractive being the traditional milling, come in and remove material.
Yeah.
As an example, probably one of the first big applications of hybrid will be repair. Mold repair or part repair. Take a part on a big aircraft carrier where it gets dinged and a part is broken, and then they got to scrap the whole $1.1 million part that will take 8 months to replace. Well, now they can just take that part off, print some material in the damaged area, then come back in and precision machine it. That's hybrid machining. That's just one application of where hybrid machining can go. But I think this becomes very exciting. The adoption of additive and subtractive machining all in one environment. Well, guess what that's going to do? These machines are being designed and built. We're in the infancy now. There's a few companies that are starting to get them. Well, what is that doing? That's driving software to say, we got to keep up with this technology. We now got to be able to, and believe me, 3D printing is the antithesis of CAM. CAM has always been subtractive. Well, all suddenly we got to start dealing with additive, meaning add material, not remove material. And that's a whole different world. So, but that's exciting. I think that's a trend that's coming. And we're very much just on the very first beginning of this, very much in its infancy.
I agree. There's companies, I think Matsura and Makino, I think, are some of the companies that come to mind. But beyond the idea of, refabricating, it's right in the fabrication process. You imagine in the old days when we had to make some fairly complex parts, we'd have to get some really long reach tools or some really long end mills to be able to achieve a cutting process where we'd have to eliminate vibration and get what we needed to do. But if you have this hybrid machining, now as you're building the part, you can be machining right at that internal level.
Now with very short tools, you can be machining precision holes, they're very deep holes, as you build them up. Instead of top down, you're going bottom up.
Yeah.
A lot of manufacturing advantages to hybrid. And again, that combined with AI, and we're on the precipice of the next generation of CAD CAM technologies.
Absolutely. Even in the world of robotics, where robots actually are working together in the manufacturing process as they, in the fabrication world, informing where you may have had to make a mold, you can now create a form for sheet metal with two robots working together.
Mm-hmm. Yeah. And again, even robotics, which has been in the manufacturing world for a long time, and CAM systems are truly starting to support them. But even that's still, it's not in its infancy, but it's not where it's going to go. Even robotics, again, lack of skilled trade. Guess what? Set up a cell with 4 machines with 2 robotic arms now, but you still need that one programmer driving all those machines. Right now, but you need a piece of software that can drive all aspects, as I like to say, drives the cutting, which most CAM systems will do, and the non-cutting motion. i.e. the robotic arm loading of the part, the robotic arm taking the part out, and not many CAM systems drive the non-cutting motion.
Absolutely. Yeah, we've got some interesting times ahead watching what's going on, and it's ever evolving, that's for sure. When we think of, robots and where they're being used, I mean, they're being used in Japan in 7-Elevens and in places to restock. And even, I don't know that it's in Walmart, but there are some stores that are using scanned robots that scan up and down the aisles to see what new inventory needs to be brought in.
Yeah, even for cashing out now, you're going to be robotic. I mean, it's just, again, labor shortages drive technology. I hate to say it, but they do. They drive technology, not just in the manufacturing world, but in many different applications and sectors throughout the world.
Absolutely. All right, so that brings us to our last question. What advice would you give to someone just starting up their career in the CAD/CAM field?
Well, I think we touched on quite a few things throughout this conversation. One is leverage all the training resources out there. And again, there's incredible training resources. But the thing I'd really drive home is you're on the right path. Keep going. You're on a path where you're going to have a great and very exciting career. And I would say go ahead and keep doing that. Again, you're on the right path for that.
Well, when we look at our title, Navigating the CAD/CAM Landscape, and certainly, my digital background here is kind of filled with robots and technology, and your background is filled with some legacy, but it's a landscape. And if they were trying to replicate that lighthouse and that structure today, some of the craftsmen, probably all of the craftsmen that were used to build that lighthouse and home are probably no longer with us.
Oh, agreed.
And would the craftsmen of today be able to put something like that up together as well as they could? Probably not. It would be a bit difficult to find those kinds of craftsmen. So when I think about this question, I think about, what advice would you give somebody? And this is one of those things where if you want it, just go for it. Jump at it. And whether you have the training or you don't, if you have the desire and the will to get into the field, there are companies jumping at your type of mentality. The guy who wants to work, they're going to hire you.
They're going to hire you, and they're even willing to invest in your training in your future. Again, the future is so exciting with the technology that's coming. Again, I've said it 100 million times. I'll say it again. Today's manufacturing is not your grandfather's manufacturing. It's full of technology. You have to be, roughly speaking, you have to be more computer science than you do have to be any other type of job. To be in the manufacturing world, you're going to be tied into computers and software and solutions to drive the manufacturing. So, as I was saying, if you have the desire, and you said it very well, Al, go for it. Do it. There's a very, very bright future in this. And again, we have a huge gap in this country, skills gap. We need people backing up these people that are starting to retire out that have all the skills. We need new skilled people.
I think on the recent movie with Tom Cruise and the Top Gun Maverick, where he told Rooster, just do, don't think.
Yeah.
And sometimes there's a point in time where you don't need to spend 8 years in school. Just go do it. Go to a company who you want to work for, and who has the technology that you want to learn, and they will take you on.
They will, and they will invest in you if you're the right person, showing the right aptitudes and the right desires. They will invest in you. I hear this throughout so many companies I go visit that talk about, there's companies that have actually reinstated apprentice programs. Yeah. That was an old school thought that went out decades ago, but it turns out that No, that was a really good thing, and we shouldn't have stopped doing it. And companies are starting to reinstate apprentice programs. So, hey, as my friend says, why not get paid while you learn?
Well, absolutely. And it was the way it was always been, yeah. So in your day, my day, and our parents' day. And that's what made Craftsman. And that's what this is all about. You want to be a craftsman in the digital world, but also, knowing what you sent to the machine, you can now hold apart and say, hey, this is what I helped make.
Yeah, absolutely. You know what? I'll give you a very good example of that, Al, before we cut off here. So one of our GibbsCAM biggest customers, our best customers, is a company called Next Intent, and they made a lot of parts that went on the rover's domain. Well, a lot of these people that made these parts at Next Intent were machinists, right? That's who they were. They weren't all rocket scientists. They were machinists. Could you imagine being that machinist that says, yeah, I made some parts, they're on a vehicle and it's on Mars. And oh, by the way, it outperformed its life cycle by like 100x.
Yeah.
Just being able to say, I made some stuff and it's on Mars. How many people get to say that?
Absolutely. Absolutely. To be a piece of that story is great for you, great for your children, and certainly great for the legacy. Eh?
Yeah, absolutely.
Well, Bart, this was quite an interesting navigation down this road. I appreciate it very much. It was great having you on. As always, I haven't had you on the show before, but I do want you back. Your understanding of the world of CAD/CAM is quite interesting, and there's so many different roads we can get down.
Absolutely. That just about any one of these one questions could almost be its own podcast.
Oh,
truly.
It makes an hour go by really, 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 really quick.
It does.
So, Bart, thanks again for joining us. Appreciate it very much, and we look forward to seeing you again.
Yeah, I'll talk to you soon, my friend. Thank you for everything.
Take you.
Care.
Cheers. Bye-bye.
Cheers. Bye-bye.
Thank you for tuning in to the Cutting Time CNC Podcast, where precision meets progress. We hope you've gained valuable insights into CNC manufacturing and are inspired to optimize your processes for efficiency and innovation. For more resources and to connect with Al or Stephanie, visit us at cuttingtimecncpodcast.com. The link is in the show description. Remember, the journey doesn't end here. Keep exploring, keep learning, and keep pushing the boundaries of what's possible in CNC manufacturing. Make sure you follow the show on Apple Podcasts, Spotify, or your favorite player to get notified about new episodes of the Cutting Time CNC Industry Podcast.